Good morning friends, this is Rambabu Asam Setti, lecturer in chemistry, Government Degree College, Perumalpuram, East Godavari district. So today we are discussing about the Diborane, its structure and preparations and some of the properties. And before going to the discuss about the Diborane, so first of all we can discuss about the what are the p block elements and what are the different groups present in those in that p block elements. First, what are the p block elements? Means so the elements in which the outermost electron or the differentiating electron, that is the last entering electron, is enters into the p orbital. So such elements are called the p block elements. Generally, so a p block p orbital so contains three degenerate orbitals, that is px, py, pz, so which can accommodate 6 electrons. Hence the p block elements contains 6 groups. So they are starts from 13 to 18. So namely that is group 13. So this group is called boron family, and group 14 carbon family, and then nitrogen family, oxygen family, halogen family, and the noble gases. And regarding the diborane, so it is the compound of boron, that is it belongs to 13 group. So here the 13 group contains the boron, aluminium, gallium, indium, and thallium. These are called the boron family. So first of all we are going before going to the structure of diborane, so what are the compounds of boron? Generally the boron forms the most importantly the following compounds, that is boranes, boron nitrogen compounds, and carboranes. And what are the boranes? Means here the binary compounds of the boron with hydrogen are called boranes. That is, when the boron is reacts with hydrogen, and they can combinedly collectively forms the different compounds. Such compounds are called boranes. For example, diborane, tetraborane, pentaborane, etc. So this is the structure of diborane, that is B2H6. So before going to the establishment of the diborane structure, so the we can prepare the diborane by using this particular following methods. First of all, it is the simplest boron hydride. It's prepared by the boron trifluoride by the reaction with LiAlH4 in diethyl ether. That is the lithium aluminum hydride is reacted to reduce the boron trifluoride. It will give the diborane. And in the laboratory, so the diborane is prepared by the oxidation of sodium borohydride with iodine, that is Na2BH4, NaBH4 plus iodine gives rise to B2H6. In industry, it is prepared by the reaction of BF3 with the sodium hydride at 45 kelvins. So that is the reaction of preparation of the reactions of the preparations of the diborane. So then we are going to the properties. Here the diborane is a colorless and highly toxic gas. It has the boiling point 180 degrees kelvins. So diborane catches the fire spontaneously when it is exposed to atmospheric air. It burns with oxygen. So the reaction is exothermic, releasing a large amount of energy. So that is when 1 mole of diborane is burns in oxygen, it will give 1976 kilojoules. It's a very huge amount of energy. And then the diborane is readily hydrolyzed with water and forms the boric acid, that is H3BO3, or simply BOH thrice. And whenever so the diborane is reacted is an electron deficient compound, that is a Lewis acid, so that way it reacts with Lewis bases and can undergo the cleavage and then forms the adducts. So for example, diborane is reacted with so N-methylamine, dimethylamine, it will gives borane N-methylamine, and B2H6 is reacts with carbon monoxide, it will gives the borane carbonyl. And the most important product formed by the diborane, so whenever it reacts with ammonia, it will forms a adduct, and it is decomposed at the 473 kelvins. It will give a volatile compound called borazole, that is called borazine. It's a very important compound, B3N3H6. So, and this particular borazole is structure is resembled with the benzene, and moreover it is isoelectronic with benzene. That means it has the same number of electrons as like in that benzene. That's why it's called the inorganic benzene. This is the briefly discussing about the diborane and their characteristic properties. So thank you.